Today we're looking at Glencoe Accelerated Math Lesson 7-2 on combining like terms. So before we can look at how we combine like terms, we should probably figure out what a like term is and make sure that we know what a term itself is. So a term is any number or variable or number with a variable. A term is something that an operation can be performed to. So can you add by this quantity? Can you subtract it? Can you multiply it? Can you divide it? That is a term. A like term means that we have the same variable and only that same variable to the same power. For example, x and x squared are different terms. X and xy are different terms because while those are close, they're not the same. If it's not the same, they're not like terms. The other thing we have is called a constant. Those are our numbers. -2 is -2 is -2. You can't suddenly make -2 something else. That value is -2. It is constant. Okay? So, today's lesson is all about how we can combine these terms so that we can take an expression and write it with fewer terms. One of my favorite expressions is that I'm a mathematician and we're lazy. Okay? We use variables instead of writing unknown quantity all the time. Well, if there's a way for us to write the same thing using fewer characters, fewer numbers, fewer operations, we're going to do it. That's what this is about. Okay? So, if we had something like 3x plus 4y plus 3x. How many terms are present? How many terms are present in this? Yes, sir. I disagree. 3. Why is it 3 and not 2?
Because there's two different number and variable.
Okay. What are my 3 terms?
3x, 4y, 3x.
Very good, except this isn't a 3, this is supposed to be 4. Sorry about that. Does changing that to a 4 change the number of terms? No. Alright. Do I have any like terms? Yes, sir. 3x and 4x. What makes them like terms? They both are referring to the number of x's, okay? What about the 4y and the 4x? Those both have 4's. No. Because remember, 4y means that I have y plus y plus y plus y. And 4x means that I have x plus x plus x plus x. They're not the same. Okay? They're not the same. We don't even know if they're close. So, our like terms are 3x and 4x. I'm going to combine these by using first my commutative property, which says that I can take 3x plus 4x plus 4y, rewriting my problem so that my like terms are next to each other. 3x plus 4x, I add the coefficients, which are the numbers in front, and I get 7. What's my variable? Plus 4y. Can I combine 7x and 4y? No. They are two different things. I would not combine a zebra and a yak. Okay? I can't combine them. So this is as far as I go. That's my solution. questions so far? Okay? What if I had I'm looking at example 3 on page 300. 5n plus 2 minus n minus 6. Now we know that our associative and commutative properties only work with addition, so what am I going to do with this? What? KCA. Okay? Now can I use all of my properties? Yeah. Okay? How should I rewrite this to combine my like terms? Yes, sir? Go ahead. Were you trying to answer? Oh, okay. Go ahead. Around what?
It's the numbers that was by variable. The specific variable, like 5
Okay.
and 1 for the n.
So those are my coefficients, but can I put those together to combine those right now? The way that this is written? No. So how do I have to rewrite it?
With the 5n plus n, negative n, sorry, plus 2 plus 6.
Alright, don't forget your negatives. Now, when I add, I go from left to right. So do I need parentheses? Could I put them in?
Yes.
I could, but I don't need to. What's 5n plus a negative n? 4n. Plus 2 plus negative 6 is? Negative 4. Can I do anything else? Why not?
Because you don't have a variable.
So?
Because then you have to do multiplication first and then first, unless you have a variable.
Okay. Are these like terms? No. Once you have unlike terms and only unlike terms, you're done. You can't do anything else. Questions? Okay. Let's look at this one. 6y minus 3 times the quantity x minus 2y. 6y minus 3 times the quantity x minus 2y. Stop. What do you think I should do first? Okay, can I combine x minus 2y? No. But what can I do to the parentheses?
You can distribute it between the variables, like do negative 3x and negative 2, or negative 2y times negative 3.
Okay, so I'm going to KCA this first to remember that the 3 is negative. I'm also going to go ahead and KCA that so that I remember that I have a negative 2y. Then my 6y is left alone. I can't do anything with that yet. Plus, negative 3 times x is negative 3x plus Negative 3 times negative 2 is a? Positive 6. And I keep the y. This already looks a whole lot nicer to work with than what we started with, doesn't it? Yeah. Am I done? What can I do? Commutative property. Alright, what should I write with my commutative property?
6y plus 6y plus negative 3x.
Okay? 6y plus 6y is? Plus negative 3x. Put it away, keep it away. Put it away. Now can I do anything else? Could I rewrite this now as 12y minus 3x? If I have 12y plus negative 3x, could I rewrite that as 12y minus 3x? Yes. Do I care?
No.
Are they the same thing?
Yes.
Do we have to be able to recognize both? Yes. Because believe it or not, they don't let me write your state test. And as the final answer to a problem like this, you could be given plus negative 3x or minus 3x. I don't know which way they're going to write it. I'm not allowed to know which way they're going to write it. But that's a topic for another day. You, however, need to be able to recognize that those are the same thing. Okay? Questions, comments, concerns, queries, exclamations? Nothing? All right. Thank you.